Hello, so for question 4, I was asked to determine all the inflection points and intervals of concavity for f of x. I was given the first derivative as well as the second derivative over here. So for this question, realistically, all that I needed to use was just the second derivative, because through the second derivative, we can find the point of inflection as well as the intervals of concavity. Now, this question was very similar to the intervals of concavity question in the last question. The only difference is that this is actually a rational function. So automatically I knew that since this is a rational function, there should be a vertical asymptote when x equals 0 in the denominator. But I also knew that when the second derivative of x equals 0, that is where the point of inflection is. So I basically made the second derivative of x equal to 0. But I treated each line as a separate. So I treated the numerator as a separate line than the denominator. So I basically found that for the numerator, when x is equal to 2, the numerator is equal to 0. And I found out that when x is equal to negative 2 in the denominator, that's when x is equal to 0. So because x at negative 2 makes the denominator equal to 0, I instantly knew that there's a vertical asymptote at x equals negative 2 on the graph of f of x. So that only left me with the other x, which is x equals 2, and I knew that that 2 represents the x value of the inflection point, because that's the only other x value left when the second derivative of x equals 0. So basically did another interval chart. The only difference between this and the previous question is that there's actually going to be like one more interval section here, and that's because due to the vertical asymptote that we have. So the first interval I used was negative infinity to negative 2, and that negative 2 represents that vertical asymptote. And the reason it comes first is, as I said in the previous video, we always take the smallest x values first, and then we basically go in numerical order. So the first interval is negative infinity to negative 2, and I plugged in a number between negative infinity and negative 2, which was probably like negative 5. And I found out that it's a positive number, like the second derivative of x. In this interval, when you plug a number in, you'll get a positive number. And what that means is that on the original function, it's going to be concave up on this interval. So from negative infinity to negative 2, on the original function, f of x is concave up. And then I did the same for the interval negative 2 to 2. This represents the vertical asymptote all the way to the second root that we have. And then from 2 to infinity. And I did the same thing, and I basically found that from negative infinity to negative 2, it's concave up on the f of x, and then from negative 2 to 2, it's concave up as well, and then from 2 to infinity, it's concave down. Now, the final part left in this question was to find the point of inflection. And like I said before, when we made the second derivative equal to 0, we were basically left with two x's, one that's negative 2 and one that's just 2. And we know that the negative 2 represents a vertical asymptote, so we can automatically know, like we can cancel out that negative 2 as being the inflection point, because it is the vertical asymptote. So the only other point we're left with is the x equals positive 2. So we just take the 2 and we plug it into the original equation, and we're left with a quarter, and that is the y value of the inflection point. Therefore, the inflection point on the graph of f of x is 2, 1/4. And that is how we can determine all the inflection points and intervals of concavity of f of x when it is a rational function. Thank you so much.